Today we solve problems related with the lenses. First problem. A thin converging lens of refractive index 1.5. So refractive index of the lens is given, that is 1.5. Has a power of 0.5 diopter. So refractive index is given and a power of the lens is also given. When this lens is immersed in a liquid, so the lens is immersed in a liquid, so it acts as a diverging lens of focal length 2 meter, the refractive index of the liquid. So here we have to find out the refractive index of the liquid. Mu is given. Mu is equal to 1.5, that is mu 2. Mu 1 is equal to 1 because in the first case lens and air is in contact. So refractive index of the lens is 1.5, refractive index of air is 1. So in air, our equation is 1 upon f is equal to mu 2 by mu 1 minus 1 times 1 upon r1 minus 1 upon r2. Here power is given. Power is equal to 0.5 diopter. Actually P is equal to 1 by F. So 0.5 is equal to mu 2 1.5, mu 1 1. Mu 1 is the refractive index of the air and mu 2 is the refractive index of glass or lens. So by putting the value we get 1.5 minus 1 times 1 upon r1 minus 1 upon r2. So 1.5 minus 1 is 0.5. 0.5 cancel. So the result is 1 upon r1 minus 1 upon r2 is equal to 1. Again, in liquid we use the same equation. So here focal length is given, f is equal to 2 meter. So again we use the same equation. So 1 by 2 1 upon 2 is equal to 1.5 upon mu 1 minus 1 times 1 upon r1 minus 1 upon r2. So here when the lens is immersed in liquid, it acts as a diverging lens. So focal length is minus 2. So minus 1 upon 2 is equal to 1.5 is 3 by 2. So 3 by 2 mu 1 minus 1 upon times 1. So again rearranging the equation, 1 minus 1 upon 2 is equal to 3 by 2 mu 1. Then 1 minus 1 by 2 is 1 by 2. 1 by 2 is equal to 3 by 2 mu 1. So mu 1 is equal to 3. So the refractive index of the liquid is 3. Next problem. An object 1.5 centimeter high is placed 10 centimeter from the optical center of a thin lens. Its image is formed 25 centimeter from the optical center on the same side of the lens as the object. The height of the image. So the given quantities are HO, that is height of the object is given, that is 1.5 centimeter. So height of the object is given, that is 1.5 centimeter. So here one condition is given, that is the image is formed on the same side of the lens as the object. So image and object are on the same side. So u is the object distance, that is minus 10 centimeter. Again, image distance from the lens, that is v is equal to minus 25 centimeter. So here we have to find out the height of the image. So the equation is m is equal to hi upon ho is equal to v upon u. That is the equation for magnification. So by substituting the values, we get minus 25 upon minus 10. That is equal to 2.5. So m is equal to hi upon ho. So m is given, m is calculated. So hi is equal to m times ho is equal to 2.5 times 1.5, that is approximately 3.75 centimeter. Next problem, an eye specialist prescribes spectacles having combination of convex lens of focal length 40 centimeter in contact with a concave lens of focal length 25 centimeter. The power of the combination. So here two lens, one is convex and other is concave, and focal length of both of the lenses are given. We have to find out the power of the combination. So if two lenses are in contact with each other, or in the case of combination of lenses, we use the equation 1 upon f is equal to 1 upon f1 plus 1 upon f2. So f1 is equal to 40 centimeter, f2 is equal to 25 centimeter. For a concave lens, focal length is minus, so f2 is equal to minus 25 centimeter. So by substituting the values in the above equation, we get 1 upon f is equal to 1 upon 40 minus 1 upon 25. LCM is equal to 200. So 1 upon f is equal to 5 minus 8 upon 200 is equal to minus 3 upon 200. So f is equal to minus 200 upon 3 centimeter is equal to minus 2 upon 3. That is 1 centimeter is equal to 10 to the power minus 2 meter. So focal length is converted to meter. So f is equal to minus 2 by 3. Power is the reciprocal of focal length. That is P is equal to 1 upon f is equal to minus 3 by 2 is equal to minus 1.5 d, diopter. Diopter is the unit of power.